All right, how's everybody doing? Yes, rough crowd, rough crowd. Well, my name is Paul, and thank you for being here. There was a little bit of a switch up, just so you guys know. It is my pleasure to introduce you guys the Technical Support Manager and Developer for Nagios, Scott Wilkerson.
Thank you. So today we're going to be talking about passive monitoring solutions for remote networks. There's several different types of monitoring, obviously, that you can do with Nagios. And so today we're going to kind of touch on the difficulties and challenges that occur when you're trying to monitor remote networks, specifically firewall challenges. And there's a couple different types of monitoring that Nagios can do. Most of you are familiar, but some of the people that are new to Nagios may not be aware that besides having Nagios actively check various hosts and services, you also have the ability to have passive checks return results back to the Nagios system. So we'll kind of go over the differences between the two. And then I'm going to present a couple possible solutions to help with the challenges of the firewalls. And one of those is the Nagios Remote Data Sender, as you heard briefly about that with in the keynote speech. And the other one is a new product that we're going to be offering called Nagios Reflector. And then we'll finish up with a little Q&A at the end. I'm definitely not afraid of questions, so you feel free to ask away once we get to that section. So we'll go ahead and talk first about some of the differences with monitoring remote networks using active checks or passive checks. With active checks, there's challenges getting through firewalls. If you're monitoring a remote network, a single machine is obviously really easy. You can just either map the specific port that you need to access through to the machine you want to monitor. However, doing active checks for many machines on remote networks presents a lot of challenges. First off, it can be cumbersome to open many ports in the firewall for every specific machine. Another problem is you may not even know what the specific device's IP address is. For example, if you have a laptop that's just obtaining IP via DHCP, could be even a company or corporate laptop that's in accessing through Starbucks wireless access. So those are some problems. Also, with multiple levels of NAT and firewalls to go through, you may have to do several of those translations just for a single system. So you have to figure out what port's going to what system, and the dynamic IPs can be a challenge if they're not being assigned by a corporate DHCP server. With passive checks, every monitoring change requires update to configuration. So if you were to set up passive checks with a traditional method, every time you need to change the configuration of the checks that you want to send back to the Nagios server, it requires logging into the individual machine, updating the configurations that you're sending back. For the passive checks to work, the Nagios server obviously needs to be reachable from wherever the device that it's sending. So we're going to look at a couple different ways around these problems, and then I have some video that will show of some of the new products that we're releasing that kind of go cover those. So generally speaking, here's what most infrastructures are like. You have a Nagios server, likely behind a firewall, maybe, maybe not. Then you have the public network, and you would have a private network on the other side with various machines that you're trying to monitor. And a lot of infrastructures is even more complex than this because you may have several layers of the firewalls that you need to punch through before you get to the remote device that you're trying to reach. Before I go any further, has anyone in the audience seen or utilized the Nagios Remote Data Center, NRDS? Kind of crickets. It's pretty new. I came to Nagios in December of 2011, and one of the first projects that I worked on was this Nagios Remote Data Center. I actually named it NRDS, or we call it NERDS. because it was kind of interesting coming to Nagios. I had about 15 years experience in the IT industry, and so I made myself a little cheat sheet of some of the acronym soup that goes around. So in the industry, I had become very familiar with the following acronyms: ICMP, TCP, UDP, HTTP, POP, IMAP, SMTP, FTP, LDAP, AD, SNMP, WMI, XML, JSON, RRA, RRD, HTML, CSS, SSH, RDP, DNS, and VM. But when I came to Nagios, there's a whole slew of different acronyms that I wasn't previously familiar with. The first of which is Nagios itself. It's a recursive acronym, including its own name, which is kind of weird. And so I was tasked to work on the Nagios XI project, which is also written in PHP, and it utilizes some add-on components such as NRP, NPCD, NDO mod, NDO to DB, OCSP, OCHP, PNP, MRTG, BPI, NSCA, NRDP, CCM. It's just an acronym soup. So I kind of jokingly added to the acronym mess by naming this NRDS. But it was appropriate because it is built on top of the NRDP backend. So NRDS stands for Nagios Remote Data Sender. And what it does is it communicates with the add-on module to NRDP. Are folks here familiar with the NRDP add-on to Nagios? What NRDP is that is a similar to NSCA. It gives you the ability to send in passive results to your Nagios system, but it was designed as a NSCA replacement, and it utilizes HTTP and HTTPS protocols for sending the data in. So it's accessible via an XML API. You can send results into the NRDP server, and it plugs them right into Nagios, which is pretty slick. So NRDS was an add-on that we developed to kind of fill a need, and so the NRDP service is extendable, so we can add plugins which basically allow you to do extra things in that XML interface. And so some of the key benefits of the NRDS server is we can create a configuration and have a custom build that you deploy once out to your remote machines that you want to monitor, be it laptops, they can be Windows systems, Unix variants, AIX, Solaris, Mac OS. And so you deploy this once, and the system automatically, every time it sends check results to the Nagios server, it also asks the Nagios server if there's a newer version of the configuration. If there is a newer version, the system will automatically download that new configuration, which contains all of the checks that are going to be performed on the remote system. At the same time, it deploys the plugins. So when you run checks against any of your systems, you will need plugins to perform that, and then issue the results and the status back to the service. So it automatically deploys all the plugins, and the system's smart enough to realize that it deploys Windows plugins to Windows machines, Linux plugins to Linux machines, AIX plugins to AIX machines. These configurations that are created are also have the ability to be shared. So you can set up a group. Say, for example, you can create a configuration for your Linux server group if you want them all to monitor the same metrics. You put in all the checks that you want it to perform on those Linux servers, deploy that package out to the servers. Anytime a configuration change is made on the Nagios server, you'll automatically update every server in that server group with all the needed plugins and the new configuration. And as I had mentioned, we have many platforms that this is available on. So how do nerds work? Well,